Okay, here we go. So today we're doing factorials. Okay. So to ease into it here, let's look at this question. So 5 friends are posing for a photo you are taking. And if they stand next to each other, facing you, how many possible arrangements can you have? So we have 5 friends who are going to stand beside each other. How many arrangements across can they have? So if you look back to yesterday, it's pretty much multiplication here. I have 5 options of friends who can go in the first spot. Then I have 4 people left, then 3 people left, then 2 people left, then 1 person left. So that is 5 times 4 times 3 times 2 times 1. And that's going to equal 120. Now, what you won't know is that also equals something called 5 factorial. So a factorial is whatever number you put there, you count down from and you multiply. In this case, 5 factorial is the same as saying 5 times 4 times 3 times 2 times 1. If I had 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, that'd be 8 factorial. And the way you can use your calculator, if you go to your calculator, mine has a button that says n factorial. It may just have the exclamation mark. It may have a box exclamation mark. Mine is behind my 4 here. So if I go 5, second function here, it gives me the factorial, which does 5 times 4 times 3 times 2 times 1, which is a lot easier to do than putting all that into your calculator. It's just going 5 factorial. Okay? So if I had 7 letters, how many combinations, let's make that orders, can be formed using 7 different letters? So 1, 2, 3, 4, 5, 6, 7. No repeats. It would look like 7, 6, 5, 4, 3, 2, 1. So if we had A, B, C, D, E, F, G. Let's say I put an A here. I'd have 7 options left. Let's say 6 options left. Let's say I put a D here. I would have 5 letters left to choose from. E, I have 4 letters left. F, I have 3 letters left. G, I have 2 letters left. Let's say I put a B there. I have 1 letter left for the opposite one. And it'll work as such. That's why, now that could be written as 7 factorial. And 7 factorial is equal to 5,040. Now you can see how much it goes up there. Like it's only the difference between that's 7 factorial and 5 factorial is 120, right? But between there, we're times this number by 6 and then by 7 again. So it goes up really quick. So on your calculator right now, see what 4 factorial is. See if you can get an answer for that. Now 4 factorial is equal to 24 from, 4 factorial is equal to 24. Now what happens when you put in 100 factorial? What are you going to get there on your calculator? 100 factorial gives you an error. And that's simply because the number is way too big to have. Like there's not enough space in your calculator, even with the scientific notation. I wonder if you can even do it here. Let's ask Google what 100 factorial is. Oh, did it know it? Oh, there we go. 9.3 times 10 to the 157. So that would be, if I did do it, you get an error in your calculator because it's just too big. Now Google to it was a 5.3 times 157, 10 to the 157. So that means if we move this over, there's going to be 5, 3, and 156 zeros going this way. That's how big that number is. So sometimes you just can't do a factorial. Now, what does 10 factorial over 5 factorial mean? So if we write this out, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, that's this one here. And then if I do 5 factorial, I'm essentially going to get 5 times 4 times 3 times 2 times 1. Now, we can eliminate here. We can cancel. So 10 factorial or 5 factorial, we're just left with 10 times 9 times 8 times 7 times 6. Okay. Can you work out this one by yourself? Now, you don't have to write all the numbers from 83. Maybe go 83 down a little bit to figure out where we are. This is where I remind you to pause your show. Not the show. I'm no show. So I have 83, 80, 82, 81, 80, 79, 78. On the bottom, I would have start at 79, start at 79, and then 78. And these are going to cancel all the way down. So we're left with 83 times 82 times 81 times 80. Now, this is good to know on assignments and tests. If you know it all, if you can answer your question in this factorial, you'll get a higher communication mark. Not a wrong answer if you don't do it. Okay? So let's use this one here, for example. You're not going to get a wrong answer if you don't do it. So how many letter words can you create using 7 letters? So let's say we have A, B, C, D, E, F, and G. Now, we're going to have to say any combination is a word. So let's draw 3 lines. How many options would we have for the first one? This is kind of what we did yesterday still. We have 7 options for the first one. Let's say we use G. We have 6 options for the next one. Let's say we used A. We have 5 options. So that's 7 times 6 times 5, which is going to equal 210. We could also write that as 7 factorial over, and I look at what number is missing. What's the number that's missing, or what's the next number? The next number would be 4 over 4 factorial. That's also going to equal 710. Because if I wrote these out, 4, 3, 2, 1, divided by 4, 3, 2, 1, this would be canceled out here, and we'd be left with the same thing. All right. So, a school choir has rehearsed 5 songs for the upcoming Mass. In how many different orders can the choir sing these songs? So we have 5 songs to be sung. 1, 2, 3, 4, and 5. How many different orders could we sing these? I'll let you answer it real quick. And we'll go back this way. We have, it was 5 options for the first one. There's going to be 4 songs left, then 3 songs left, then 2 songs left, then 1 song. So it goes 5 factorial, which equals 120. Now, hypothetically, if you can answer in factorial mark, your communication mark would go up. Right? That'd be like a 4+ level if you go all the way through. This is not a wrong answer. This is still a correct answer. Now, we're going to change some stuff up here so we do some thinking. So, of the 5 songs, you decided that Lord of the Dance must be the closing song. 2, 3, 4, 5. So, Lord of the Dance has to be closing. So there's one option to go in this slot here. That would leave 4 options for the first song, 3 options for the second song once I do that one. 2, then 1. So if I had Lord of the Dance, let's say I have song, I'm going to give it these two things, KK and SL and MM. Let's say those are all my songs. Lord of the Dance goes there, so it's gone. Then I have 4 options left. So let's say I'm going to use KK here. So I have 3 songs left. I use MM. I have 2 options left and then 1 option left. Okay, and that's how we get. Now that would be 4 factorial, just straight 4 factorial. So it's 4 times 3 times 2 times 1. And times 1 doesn't really do anything with it. All right. Now we're going to get tricky. The choir has decided that hands and Lord of the Dance, so say H is hands, Lord of the Dance, we have SS, MM, and LL. Those are our songs. These have to be beside each other. So what we do here, and it's beside each other, is we're going to make a box here. And Lord of the Dance, these two are going to go in the box. Now, I didn't say which one has to go first. So Lord of the Dance could go first, or hands could go first. So within this box, there's 2 options to go in that spot. Right? And let's say we used hands. And there'd be 1 spot, 1 option for the second spot. Okay? Let me make that a little bit better. So 2 options for the first spot, and then 1 option for the second slot. Because once I use hands, I can't go there. Now, the weird thing here is I didn't tell you where I want it to go. So that group of songs could move anywhere in there. It could go first. It could go second and third. Anywhere in there. And the way we handle this is now, we do the same thing here. Now we're going to treat this set of 2 as one big song. As one song. So now, if you look at it, we have 1, 2, 3, 4 options of where it could go. And let's say we use LL first. Now I have 3 options left. Let's say I use SS. Now I have 2 options left. Let's say I use this one. And I have 1 option left to go there. So the answer for this one is going to be 4 factorial for this part. And 2 factorial for this part. So it's going to be 4 factorial times 2 factorial. Okay? Now what if I said, so it was Lord of the Dance and hands have to be the first 2 songs. In any order. So these can go in any order. Okay? So I'd still kind of do my 5 here. And I know these have to be the first 2. Those are the first 2. Okay? Now within that, I don't know which one goes first. So I'm going to put 2 there because I have 2 options which goes first, whether it's Lord of the Dance or hands. Let's say it's Lord of the Dance this time. Once I use that, it goes here. Now, I said it has to be the first 2 songs, so it can't move. So unlike this one where I made it essentially it's one song and it can move around, it can't move, so I can't put anything else there. So I have 3 songs left. Let's say it's MM, LL, and SS. So I have 3 songs to go in these 3 slots. So that'd be 3, take away 1, 2, and 1. So the answer for that one would be 2 factorial coming from that times 3 factorial. Okay? Now let's keep playing with this. What if I wanted hands to be the middle song? Hands has to be the middle song. How would that look? Hands, Lord of Dance, SS, LL. Those are my 5 songs. So if Hands has to be the middle song, I'm going to put it there. Hands has to go there, so there's one option that can go here. Then, of the other ones, so now Hands is gone. As I fill everything in, whether you count this like this way or that way doesn't matter. Let's count this way this time. Now I have 4 options left. So I'm going to go 4 songs to go to that spot. Let's take away this song. Now I have 3 options left. Boom, it's gone. I have 2 options left. And now I have 1 option left. So the answer there would be 4 factorial. All right. Let's keep... I'll let you do this one by yourself. So 7 people are getting their picture taken. I apologize for my amazing writing. These 2 people, let's say Sam and Allie, have to be beside each other. So 7 people, Sam and Allie have to be beside each other. That's the only restriction. So pause it here if you want to take a shot at it. So here's your answer. 1, 2, 3, 4, 5, 6, 7. So they have to be beside each other, so we're going to box them up. Now I didn't say who's first, who's second, so that means there's 2 options to go first. Let's say Sam goes first, then Allie goes beside. And I didn't tell you they have to be anywhere in particular, so we're going to treat them as one person. And now we have, let's say there's 7 people here. Allie, Sam, Mike, Mick, Matt, 1, 2, 3, 4, 5, Millie, 6, and Jim. Okay? Now these guys are boxed up together. So there's one person. So now I have 1, 2, 3, 4, 5, 6 options. So I have 6 options there. Let's say I use Jim. That means I have 5 people left. 5. Let's say I use both of those. Then I have 4 people. 4 person left. Then 3, then 2, then 1. So my answer for this question, I have 6 factorial from here. 6 factorial times 2 factorial. So I have this one here, and these guys can also move in. All right. So now, Allie and Sam got in a fight, and they have to be at either end, at the end of the line. They have to be as far apart as possible. Right? And let's leave it at that. They have to be as far apart as possible. I'm not telling you one has to go at the front, one has to go at the back. They just need to go as far apart as possible. So I'm going to put Allie and Sam in their place first. They're going to go here and here. Now, I didn't tell you who goes where. So we have 2 people that can go there, Allie or Sam. And then the one that's left over is going to go there. So if we pick Sam, then there's only one person go at this end. Then the other friends, we have friend 1, 2, 3, 4, 5, because Sam and Allie are the 6th and 7th friends. So now we have 5 people left to go in these 5 spots. So we have 5 options to go there, 4 options there, 3 options there, 2 options, and 1 option. So that'd be 5 factorial times 2 factorial. Now if we did this on a calculator, 5 factorial times 2 factorial, should get 240. So there's 240 different arrangements that we could set those friends up to be. Okay? Let's go with this one. There's 12 people on a team. 5 people get introduced at the basketball game. How many orders of 5 people from those 12 can be introduced? So I have 5 people to be introduced at a basketball game. how many people how many orders could I have to introduce those people? So I always give a pause, let you figure it out. Pause it, see if you can figure it out, and go from there. So when we go to introduce people, the very first one, we have 12 people who can fit in that first slot. Right? And once we take one person out, we have 11 people left, 10 people, 9 people, 8 people. So we have 12 people in our team right away. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. We put one of them there. Let's take somebody out. Then we have 11 people. We take that person out, so we have 10 people left. Take that guy, we have 9 people left. That one, we have 8 people left. Okay? So that would be the answer as well. You could just plug that in your calculator and give me the answer. Now, if you want to write as a factorial, it would look like, okay, what number is missing? What number is my next one missing? My next one missing 7. It would look like that. Okay? I'm trying to think of what other tricks we could do. Let's do this one. So let's go 5 friends. 5 friends, and Allie must be in the middle. Okay? I'll give you a second to find that through or work it through. So we have 5 friends. Allie must be in the middle. So there's going to be a 1 there. And then we have 4 friends left. 3, 2, 1. So the answer is going to be 4 factorial, which equals 24. Okay. How about this one? 12 people on a team. 5 get introduced. You and your friend, let's just say you are one of the 5. You're guaranteed to be one of the 5. How many different orders, okay, could we do this? So let's put you in first. How many U's are there? There's 1 of you. Then after that, there's 11 people left to pick from, 10 people left to pick from, 9 and 8. So I could write that as 11 factorial over 7 factorial. Okay? If we did the exact same thing, and I said you and your friend and your 2 friends, and your 2 friends get introed. So you and your 2 friends get introed. Let's just do that. I wonder if I have to add. Let's go get intros first. So you're going to be the first 3 introduced. Your first 3 introed. Okay. Pause here and think about that. I need to put you and your friends right here, here, and here before we get started. Well, that would mean there's 3 here, as you have 3 options of who could go first between you and your friends. And there'd be 2 of you left, 1 of you left. Then we have to fill out the rest of the team. So I mean 12, 11, 10. We've got 9 and 8 here. So after your 3 friends, there'll be 9 people left in the team, 8 people left in the team. If I wanted to write that, would be 3 factorial divided by 9 factorial over 7 factorial. And lastly, what if I just said You and the 3 friends introduced next to each other, introduced together. What's the word I want to look at? Oh, geez, I lost my word for introduce one after another. There's a special word for that. One after another. Okay. So this one we're doing the box method again. We're going to box them up. But I didn't tell you they had to be first. They could go anywhere. So in the box, we're going to go 3, 2, 1, because that's your 3 friends options. Then we're going to treat you as one person. And we're going to go, let me think here. Here. So I need to think this out a little bit. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You 3 are one person. So realistically, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options. So that would mean I would go 10, 9, 8. Because I have 10 options. Once I grab this person, there's 9 left. And I have to take this person. And then there'd be 8 left altogether. So that would be 10 factorial over 7 factorial. Would be my answer. Okay? That's a lot of options, lots of thinking. Hopefully just follow through with the questions and we'll keep throwing questions out. But really good job and do the homework and we'll go from there.